Hello everyone, good morning. Are you able to hear me?
Yes, sir.
Okay, okay. So let's start our today's discussion. So let me share my screen quickly. So today we will discuss about the shared variables in Spark. And in our last session, we have seen RDDs, transformations, and actions. So hope everybody practiced all the transformations and actions in Spark RDDs. Okay, so that is the Spark core part that we have discussed. Okay, so today we will discuss about shared variables, which is very important concept in Spark core, and also we will see how to deploy a PySpark application from outside to the Dataproc cluster. So that is one more thing that we are going to see today. Okay, so quickly, I have my cluster here. Okay, so before going to this, so let's see the introduction to the shared variables, right? So shared variables meaning, so in Spark, sometimes you may need to declare few variables which are required across the cluster. Okay, so that is the major uh, importance of these shared variables. Okay, so if you declare all the Python variables, or if you see few variables are very large, and uh, if you want to store them as the Python variables, what will happen? So here you will be having your driver. Okay, and all the variables, so you will be having your driver, how we are creating accumulator and how we are using it in our application. Clear?
Yes, yes.
Yes, Venkat.
Okay, fine. So let's see one more example here. So here, if you see, I have product categories. So which is a dictionary. Uh, okay, so which is holding, P1 electronics, P2 electronics, P3 clothing. So this is a product categories dictionary, and then here I have a data. P100, P2 150, P3 200. So this is one of my sales transaction data, which holds a product ID and amount. Okay, so this is my sales RDD, and I have product categories. So here, if you see, I'm creating the broadcast variable for my product categories, and I'm also creating the accumulator to identify the invalid transactions. Okay, so now here, if you see, I'm creating a function called map to category. Okay, and I'm taking each sale. Okay, I'm taking each sale, and under each sale I'll be having product ID and amount. Correct? So this is one sale, right? So one sale I'll be having, I have product ID and amount. Now, if a product ID in broadcast categories dot value, then category equals to, so I'm extracting the category, and I'm returning it. So instead of product ID, I want to see its product category, right? So that is what we are doing it here. So and then else, if the product ID is not in your static variable or broadcast variable, then what will happen? We are treating that as an invalid transaction, and then we are adding the element. So see here, guys, a proper business use case to use your broadcast variables and accumulators, right? So and then you can call everything that you need. Okay, see here, you got your categories instead of IDs, and the invalid transactions also you got. Right, guys, are you able to understand this example? Transaction sales example using broadcast variables and accumulators. Okay, so here's the same, guys, the same RDD you have, and then map, you call the function, and then filter x is not none. Okay, that's it. So it will return the not none. I mean, if the condition is not satisfied in your function, so it will come as none. So that's why we're applying the filter. And you can always split this and then see the RDDs, assign it to one RDD, and filter, assign it to another RDD, and reduce by key, assign it to another RDD. I'm not assigning it to multiple RDDs. I'm writing them in a single line. So you can assign it to multiple RDDs and debug the data in each step, so that you will get more clarity how actually the data is coming in. Okay. So and here finally I'm collecting it, and I'm printing the accumulator value. So that is what I'm doing here. So there is nothing rocket science, guys. This is very simple implementation. Okay, so what I am doing now, so I will try to download this notebook. Okay, I will try to download this notebook, and I will try to upload it in the Git repository. So request you to go and download it and practice. Okay, so not only these examples, guys, I request you to search more examples, or take your own use cases, uh, right, and then practice. So then only you will try to understand how actually RDD based data is getting organized. Okay. Okay, so this notebook you can download and upload into your cluster, and then try to run it. Okay, so that's about the creation of your accumulators and broadcast variables, and using them in the program. Okay, so now let us. Okay. So what I am trying to do is I will try to deploy one of the application. Okay. So this is how you will deploy the application. So I will show you this also, guys, to you. So here, if you see here, if you have written a PySpark program, and you store that in a Python file, right? In real time, You cannot go and execute statements in the shell based environment like we are executing now. Okay, so this environment is only for your testing, developer testing. Be very, very clear. The shell-based environment is only for the developer testing. Okay. But in real-time projects, you develop programs, you develop applications. Okay. Same to our Python guys. So in Python, we have shell-based environment. Okay, so here also we can write our Python program, but we used IDE and we have written a program like thing, and we executed that program file. Correct. Similarly, for PySpark also, what we do, we develop a program in a file .py file. Okay, it is also a Python file, right? Because when you are writing PySpark program, it is a Python file only. Okay, now once you have a Python program file, then you will run that file or you will submit that file to the cluster. Okay, that is what you do in the real time projects. Okay, so now let us quickly go and see how we will deploy a Python file. So here, if you see, this is the command gcloud dataproc jobs submit. Okay, gcloud dataproc jobs submit. That means we are submitting a job to a data proc service. Okay, and what type of job it is? It is a PySpark job. Okay, okay, and where is the program file? So this is my program file. You need to specify the path to your program file, and to which cluster this job needs to be submitted. Hyphen hyphen cluster equals to jobs cluster, and where this cluster region is. Okay, hyphen hyphen region US West 1. Okay, okay, so this is the command that we will use to submit our job. Along with this command, you can pass multiple parameters also. Okay, those all things we will see slowly, but now try to understand this is the basic command that we will need to submit a Python program file or PySpark program file to a cluster from the external service. Okay, so here if you see, I'm not submitting, I'm not running this in the cluster uh, notebook. Okay, I will try to run it from my Vertex AI notebook. I will try to run it from my Vertex AI notebook. Okay, so if you see, I have word count.py. I think here. Okay. Okay, no problem. So what I will do, I will try to, yeah, here, if you see sample load count.py. Oh, here it is not there. Yeah, here it is. Okay, I'm sorry. Yeah. Okay. So here, this is my program, guys. So what my program is having, see here, I have imported my Spark context and configuration. Okay. And then I'm creating my Spark context. Okay. Spark conf.app name word count. Okay. Set app name word count. See here. Okay. And then I'm just trying to create my Spark context by using the default statements. And then here, if you see, I have a file that is there in my GCS location. Okay, I'm just trying to read that file path, and I'm passing it to my sc.text file method. We know what is sc.text file method, is it? Okay, so this method, I'm just passing my text file. Okay, so the first step, right, perform word count. So here, if you see, we know what flat map will do. Okay, we are reading each line and we are splitting that line with space. That is the first operation that we need to do. Okay, So once we have splitted each line with space, then what will happen? So your map transformation, what you are doing, you are assigning a one value for all the elements that are there in the splitted list. Okay, meaning your words will be splitted, and each word you're assigning a value called one. Okay, and then you are using the reduce by key transformation to sum up for the same word. What it will do, it will sum your values, right? So that's the responsibility of your reduce by key transformation. So each word you are assigning value one, and when you use reduce by key on top of it, what will happen? It will sum all the ones for the same word. So that's how you are deriving your word counter. You see guys, this is just a one liner, or one in one line also you can write using dot map dot reduce by key, but I have splitted it for three lines for your understanding. Okay, so flat map, map, and reduce by key, these are the transformations that we require to count the word count. We know each and every transformation, we already used it, correct? So this is all about how you implement the logic, guys. That's it. Okay, the functionality of your transformation remains the same, but how you utilize that transformation in your logic building is your skill. Okay, so you need to understand that. So flat map, we know it will return the flattened elements. Okay, first we need all the elements or words from the text file, so that is why we are doing this. And once we have all the words, then we are assigning a value one for each word, and we are forming a tuple with it. Okay, once we have one, then we are using the reduce by key transformation to sum up all the ones for the same word. Okay, so that is what the logic that we are building here. Okay, so once we have this code ready, simply we are just printing the word and then count. It's secondary. You can simply collect also this RDD, it will come. Okay, now okay, so I have my Python file, and then I'm reading the data from my GCS, and I implemented the logic. Okay, and then I'm just printing the results. So now how to submit this Python file? Okay, your code has been completed. So how to submit this Python file? Yeah, so we have discussed the command, right? Simply let's submit it. Okay, see here, I'm doing it from the Vertex AI notebook. Be very clear, Vertex AI notebook terminal. Okay, and I'm not submitting to the master node terminal. Be very clear. Okay, so you cannot submit your job directly from your master node itself. Okay, so remember, so you need to submit it from your third party service or any of the service. It may be workflow or Vertex AI notebook or a composer. You can submit your data proc job from these services, so that it will be submitted to the respective cluster. Okay, so now simply I'm just running it. Okay, so it is getting started. So to monitor this job, you can go to jobs page. Okay, or you can go to yarn portal. See here, this is your yarn portal where you can actually monitor your jobs. All your jobs will be submitted to yarn only, right? Yarn is your resource manager, right? So here if you see, you can quickly go and see your word count job got submitted here, if you see. And then you can go and check your DAG for this, guys. So okay, so this is not configured properly, I guess. The history server, yeah, it is configured. So here, if you see, this is your completed application, and then you can go here and see, guys. So you can pretty well go into this job, and then stages you can see, and the DAG you see. So this is the DAG. Okay, so text file and then map partitions, right? So under each stage, what is the DAG? You can see completed stages, you have two, and then reduce by key stage, and then collect stage. So every stage you can see your DAG. See, this is the DAG, right? So you need to understand, guys. You need to understand how to debug this DAG and how to see all your executors. See here, you can see the executors, right? And you can see active tasks that are running in. So everything you can see. Okay. So I will give you more detailed information about this DAG later. Okay, but for now, try to understand. This is how we submit it. So your entire job has been split into 4 tasks. Okay, and 1 job. So because you are using only one action, right? Collect. So that is why you got only one job ID. If you use multiple actions, so those many job IDs will get created. So the relation is if you have actions will create jobs. Okay, and then inside each job you will be having stages. Okay, transformations are responsible for creating stages. Okay, so transformations are responsible for creating stages. Inside each stage you will be having tasks. Okay, so let us take an example. In our case, we created one job. Okay, I mean our DAG created one job. Our driver will create this, guys. Our driver will create this. It will understand our code and accordingly it will create. So now one job having 2 stages. Okay, so stages are 2 in our case. Okay, and then and immediately after that you have tasks, right? So this is how our job is created. See, so you need to understand this. Okay, so once you have this, you can pretty well go to jobs and then try to see the executor logs also. You can do whatever you want, guys. You can debug this. Okay, so each stage will be having 2 tasks. Okay, so total 4 tasks you got. Okay, so because your collect also triggered a new stage. The reason being, it has to read data from all the executors, right? So all the executors needs to send the data to driver. So that is where the transfer is happening, right? The data transfer is happening. So that is the reason it created one stage. Okay, when a new stage will be created, whenever there is a shuffle transformation, then or shuffle action, then definitely there will be a new stage that will be triggered. Okay, so that is the reason you got 2 stages. Okay, you got 2 stages. So as and when you use the collect, there is a shuffle. So that is the reason it created a new stage. So your narrow transformations does not, which does not trigger shuffle, they won't create new stages. Your wide transformations, which triggers the shuffle, will create the new stages. Okay, and depending on the logic, your tasks will be created. So your tasks, how many partitions are there, those many tasks will be created. Be very very clear. One task will run on top of one partition. Okay, one task will run on top of one partition. Okay, that is the relation, guys. This is very very important in interviews. So people will ask you, hey, could you please explain me the relation between jobs and tasks? Okay, so, and could you please explain me what will be there in the DAG? Okay, then in that case, you should explain all these contents. Okay, so DAG is a physical execution plan which consists of jobs, stages, and tasks information. Okay, each job will be created from an action that we trigger. Okay, and inside each job, you will be having number of stages. Okay, each stage will be created based on the transformations that we are using. And if it is a wide transformation, then immediately there will be a new stage that gets created. Okay, and then how many number of partitions are there, those many number of tasks will get created under that stage. Okay, under that stage, how many number of partitions are there, those many number of tasks will be created. So each stage will be having multiple tasks. Okay, and each stage will be having multiple tasks, and each task will be running on top of one partition at a time. Okay, so here if you see, your entire compute job will be splitted into 4 tasks, and those 4 tasks are running in your executors. Okay, you have 2 executors, so in the 2 executors these 4 tasks are running parallelly. Okay, that is the logic of your Spark framework, guys. So you need to understand that. Okay, guys, are we clear? So this is how we will submit. This is how we will submit our a Python file to the cluster. So from today, I request everybody to stop on the shell-based program executions, because we know. Okay, so we have done practice on shell-based, and I want you to run by using script or else application based. Okay, so this is the command that we need to use. So what is there in the word count? So I'll be uploading this to Git repository. Just give me a minute. Where is my Git repository? Yeah, here. So I'm adding the file, word count file, as well as my word count program. Okay, so here these are the 2 files. So I want you to go and practice and deploy your application. Take different use cases, guys. We have seen multiple different use cases using broadcast variables, accumulators. Try to develop a big application. Use all your learned content, right? So that is something that is needed. So okay. Okay, so hope everybody understood today's session, guys. Are you clear? Anybody have any questions? Come on, guys, speak up. So are
Yeah,
you able to
yeah.
understand? Okay. Okay, fine. That's all. That's all I have for today, guys. That's all about Spark Core. Okay, RDDs. RDDs are part of Spark Core, and we have seen transformations. We have seen types of transformations. We have seen DAG. We have seen Spark architecture, and we have seen accumulators and broadcast variables, and we have seen how to run a Spark program from how to submit a Spark program to Datadog cluster, right? So we have seen a word count example, right? Everything we have seen examples, right? So this is, I mean, now it's your turn to practice your Spark core. Okay, take different RDDs, take CSV files, do processing or transformations, and then understand the data, how it is RDDs are taking on, use your transformations, right? So this is up to now. I mean, this is your turn now to practice Spark code. Okay. Now we will quickly jump into the Spark data frames starting from tomorrow. Okay. So RDD based processing we have seen till now. We will see data frame based processing from tomorrow. Okay. So tomorrow we'll be having session at 8 o'clock in the morning. Okay. So 8 to 9 is the session time for tomorrow. So I request you to attend the tomorrow's session. So it is very important. So we'll be discussing the data frames based functionalities in Spark. Okay. So majority of the times, if we have structured data, okay, that means if we have tables data, okay, if we have any JSON data, if we have Parquet data, then we always use data frames in Spark. Okay, if the data is semi-structured or unstructured, meaning if you got any text files or log files which don't have any columns as such, which has only the plain content, then in that case you will be utilizing the RTDs. You will be utilizing the RTDs. Okay, so that is about the RDDs. Okay, so in tomorrow's session we'll discuss data frames API, and I'll also give you a real-time RDD based use case to solve. Okay, so as a task. So that's all I have for today, guys. Once again, we'll connect back tomorrow. Thank you so much for joining. Yeah.
Thank you.